So find the derivative is y is tangent inverse of x over 2. So we need to remember what the derivative of inverse tangent of u is, and that is going to be 1 over 1 plus u squared times the derivative of u. So u in this case is x over 2, so the derivative of u is 1/2. So my derivative is going to be 1 over 1 plus x over 2 squared times the derivative of u. Now I'm going to do a little bit of algebra. So I squared the x, squared the 2, and then I'm going to find common denominators. My common denominator is 4. So since this is the 1, I multiplied it by 4, so I need to multiply the numerator by 4. So I get 1 over 2, 4 plus x squared over 4. So notice that these will cancel. So I'm left with 1 over 4 plus x squared over 2. And I can rewrite that as 2 over 4 plus x squared. This is 1 divided by a fraction, so you just multiply by the denominator. Multiply by the reciprocal. Okay, so we're going to find the derivative of y equals e to the negative 3x cosine of 5x. So notice this is the product. So I'm going to let u be e to the 3x. V is going to be cosine of 5x. So derivative of u is negative 3 e to the negative 3x. Derivative of x is negative 5 sine of 5x. So the derivative is going to be the derivative of u times v plus the derivative of v times u. So if f of x equals 4x squared minus 5x, find the inverse of negative 1. Okay, since we're trying to find the derivative of the inverse, this is my y value. So y is equal to negative 1. So the first thing I need to do is I need to find my x value. So to find my x value, I'm going to use the original equation and solve for x. So I'm going to factor. Two numbers multiplied together, that gives you 4x squared. Two numbers multiplied together, that gives you 1. Okay. They're both going to be negative, so if I cross multiply, that gives me my middle term. So I'm going to have 4x minus 1. X minus 1 equals to 0. Using the zero product property, set them both equal to 0. So I'm going to have two numbers, x equals 1/4 and x equals 1. So let's do the first point at 1, negative 1. Okay, I'm going to take my derivative. I'm going to have 8x minus 5. So the derivative of my y value can be 8 minus 5. So that's 3. Okay. Then I'm going to change this problem. Because remember, in order for a function to have an inverse, it has to be 1-to-1. So I'm going to make it when x has to be greater than or equal to 1. So therefore, we can't use x to the 1/4. we're just going to use x to the 1. We have to have a domain to make it 1 to 1. So since my inverse is equal to 3, the derivative of the inverse at the y value is the reciprocal. Okay, so g is going to be my inverse. So if f of the derivative of s of a is equal to 3 and f of a is equal to 6, find the derivative of the 6. Okay, so a couple things. So let's look at f of x. So this tells me that when x is 8, y is 6. And this tells me the derivative of f at 8 is equal to 3. So since g is my inverse, this is actually looking for the derivative of the inverse at the y value. Notice this is my y value. And the derivative of the inverse of the y value is the derivative of the original function at the x value, which is take the reciprocal. So let's take the derivative of each one. To find the derivative of sine inverse, we need to remember that the derivative of sine inverse of u is the derivative of u, or 1 over the square root of 1 minus u squared times the derivative of u. So u is going to be 3x, so the derivative of u is 3. So in part A, my derivative is going to be 1 over the square root of 1 minus 3x squared times 3, or 3 over 1 minus 9x squared. For B, we need to remember that the derivative of secant inverse of u is 1 over the absolute value of u, square root of u squared minus 1, times the derivative of u. So u is e to the 2x. The derivative of u is 2 e to the 2x. So my derivative is going to be 1 over absolute value of 2x e to the 2x squared minus 1 times 2 e to the 2x. So my derivative now, e to the 2x is always going to be positive no matter what we let x be. So that's why I can get rid of the absolute value. And then on top, we're going to have 2 e to the 2x square root of e to the 4x squared minus 1. Right? Distribute that squared. Notice that my e to the 2x will cancel, so I'm left with 2 square root of e to the 4x squared minus 1. Okay. For part C, we just have to use the formula. The derivative of the inverse, cosine inverse, is negative 1 over the square root of 1 minus u squared times du. So in this case, u is x over 2, du is 1 half. So my derivative is going to be negative 1 over square root of 1 minus x over 2 squared times 1 half. So we're going to do a little bit of algebra here. We're going to put these underneath common denominators. Okay. So notice that my common denominator is 4. So I multiply this by 4, so I have to multiply the numerator by 4. So I can use the definition of square root and take the square root of the numerator and the square root of the denominator. And the square root of 4 is 2. So these will cancel. So I'm left with negative 1 over the square root of 4 minus x squared. So we're going to find the derivative of each one. So the derivative of cosecant of u is going to be negative cosecant of u times cotangent of u times the derivative of u. So u is 7x, so the derivative of u is 7. So my derivative is going to be negative cosecant of 7x times cotangent of 7x times 7, or negative 7 cosecant of 7x cotangent of 7x. Okay, so the derivative of cotangent of u is going to be negative cosecant squared of u times the derivative of u. So u is 8x, so the derivative of u would be 8. So we're going to have, okay, I'm not going to use the product rule because 4 is a constant. So when it's a constant, I don't have to use the product rule. I'm going to have negative cosecant squared of 8x times 8, or negative 32 cosecant squared of 8x. Okay. And the derivative of secant u is going to be secant of u times tangent of u times the derivative of u. So u is 5x, the derivative of u is 5. So since 2 is a constant, I'm not going to use the product rule. I can just bring it down. So I'm going to have secant of 5x times tangent of 5x times 5, or negative 10 secant of 5x tangent of 5x.